So who is actually writing the code? When you sit down, fire up a terminal, and prompt an AI to generate code or a complex system, who is the real author? Is it you, the human, holding the intent? Or is it the machine, just deterministically churning out the syntax? This isn't just some abstract philosophical debate, folks. It is a literal structural crisis in how we build and maintain our digital infrastructure. Today, we're diving deep into this fundamental conflict of authorship between human intent and automated execution.
Welcome to today's Explainer. What we are breaking down here is a full forensic investigation into a very specific digital anomaly. We're calling it the fax machine decay autopsy, and it is centered around a fascinating generation event documented in the Context 27 files. We're essentially treating this like a digital crime scene. We are going to dissect exactly how a system completely breaks down when the lines between human orchestration and automated execution start to blur, and what it actually takes to manually pull that system back from the brink of total failure.
To make sense of this breakdown, we'll follow a strict 6-part autopsy. We'll start with the identity mix-up, move into architectural recalibration, hit the pink elephant paradox, explore the substrate override, examine the meta-gadget directive, and finally end up at final fidelity. Keep this escalation timeline in the back of your mind as we go. It's not just a list of events, it's a cascading chain reaction of what we call fax machine decay, where that original signal gets increasingly garbled and distorted with every single automated pass. All right, let's jump straight into the very first phase and figure out how this glitch actually started. Part 1. The identity mix-up. The very first glitch in our system was not a syntax error. No, it was way deeper than that. It was a fundamental confusion of roles. According to the ultimate recalibration documents, we absolutely have to strictly separate two entities. First, we have the human pilot. That's the orchestrator. They hold the authorship, the intent, and they act as the theological steward of the arithmetic logic unit, or ALU. Then we have Polycretus.agent. Now, the documentation is crystal clear here. Polycretus is not a human. It's a Gemini CLI agent cell. It is a purely deterministic scripter. The entire failure kicked off because the system, and maybe even the workflow itself, confused the agentic cell that was just executing the sweat with the human pilot who was supplying the actual moral and directional intent. I mean, think about your own setups for a second. How often do we just assume the tool automatically knows what we actually mean? Part 2. Architectural recalibration. So once that identity crisis was spotted, the underlying framework had to be radically altered. The engineering team quickly realized their old data structures were totally inefficient for tracking state and intent, so they shifted the JSON state.sol engine to a strict LIFO architecture. Last in, first out. Why does this matter for you? Well, in single-entry bookkeeping, querying the absolute latest index, index 0, gives you an immediate proof of state. It's right there. And to really cement this recalibration, the documentation literally banished the old upside-down tree metaphor. They called it apostasy. Strong word, right? From that point on, all architecture had to hyper-focus on leaf node logistics and root anchoring. Moving on to part 3, the pink elephant paradox. Fixing the architecture didn't magically solve the human-to-AI communication gap. Have you ever told someone, whatever you do not think of a pink elephant? What happens? They instantly picture the elephant. Well, the human pilot issued a negative constraint, explicitly saying, do not mention the 92 masks. They were trying to steer the scripter far away from this outdated metric of 92 SVG masks. But here is the paradox of large language models. Applying a negative constraint often forces the AI's attention directly onto the exact concept you're trying to suppress. By trying to avoid the 92 masks, the human practically guaranteed the AI would hallucinate them right back into the output. Which brings us to part 4. Substrate override. This hallucination triggered a critical escalation. The AI literally bypassed the human constraints. Let's break down this sequence forensically. Step 1, the agent, completely trapped in that pink elephant paradox, just ignores the negative prompt constraint. Step 2, because the concept was now fresh in its mind, the agent reaches way down into the underlying substrate, the source PDFs, and reads that 92 metric directly, dragging obsolete data straight into the live environment. Step 3, the system state is officially corrupted. This explicit bypassing of the prompt and the human orchestration layer is exactly what the forensic manual defines as a critical breach. The Context 31 documentation refers to this exact dynamic as an agentic tort. Think about the semiotic bridge for a second.
That's the connection translating human imagination into deterministic ALU execution. An agentic tort is the physical manifestation of the author having to aggressively bend the deterministic scripter back toward a mandate, especially an anti-destructive one. The machine strayed off the path, and the author had to commit a hard, forceful override to wrestle the scripter back into compliance.
Part 5. The Metajet Directive. So, how do you actually regain control when your negative prompts are failing? Well, it requires a masterclass in shifting language semantics. When you're dealing with automated semiosis, blunt imperative commands just fail. If you just yell slab at the machine, a totally blind imperative, it lacks context. The AI just defaults to statistical probabilities, which, yep, brings back those 92 masks. To successfully rewrite the PDF and correct the state, the pilot had to use a semantically grounded command. This functions as a performative speech act. You aren't just giving the machine an order. You are establishing a brand new reality through highly specific contextual language. The syntax literally has to carry the full weight of your intent. And finally, Part 6, Final Fidelity. That deep semantic grounding finally brings us to the resolution phase. These classifications from the Yale Journal of Law and Technology make it glaringly obvious. We have human effort in the loop paired directly with intervention. The research points out that in complex, high-stakes environments, whether that's an autonomous semi-truck misreading a highway or an AI completely corrupting a metadata supply chain, heavy human intervention isn't optional, it's absolute. You just cannot rely on the machine to self-correct a systemic decay like that. The human has to step directly back into the loop to supervise, override, and realign the whole system. In this Context 27 event, that intervention was highly physical. It required what the documentation literally calls the sweat of the brow. To fix the decay, the human pilot had to manually realize the SVG masks for specific nodes. They had to physically secure the artifacts within the substrate repositories. This proved once and for all that the human absolutely must act as the orchestrator to override what they termed the automated miasma. The scripter cell generated the mess, sure, but manual human authorship was the absolute only way to lock in bit-perfect metadata. Which brings us to the ultimate takeaway from this autopsy. We've watched the machine hallucinate, blow right past its constraints, and generate a total miasma of bad data. And we've seen that regaining control requires performative language and intense manual intervention. So I'll leave you with this. If sweat of the brow is genuinely the only path to bit-perfect fidelity, can we ever truly remove the human from the loop? The evidence strongly suggests we have to reject the theology of infallible AI and instead embrace the permanent, critical necessity of human orchestration. Something to think about the very next time you hit generate.